also going to graph each of these and then figure out the period. Now, if you had cos of 6x, I hope that you can see that this would be a horizontal compression because that 6 is inside of cos, and that you would multiply your x values by 1/6. Again, when we look at our normal cosine graph, you're going to get really good at graphing your normal cosine graph. As a max of 1, min of -1, draw your axes family. There's a period of 2 pi divided into 4 equal sections. And a cosine graph starts at a maximum, then center line, then minimum, then center line, then maximum. Here's our normal cos graph. If we did a horizontal compression by 1/6, that means we are squishing this whole graph in by 1/6. The strategy that we are going to use to do this quickly is to take the normal period. The normal period of a cos graph is 2 pi. If the normal period is 2 pi and we're compressing this horizontally by 1/6, can you see that our new period if the normal period was 2 pi and you multiplied everything by a 6, now your new period will be 2 pi divided by 6. And you could reduce that to pi over 3, but I'm just going to leave it as 2 pi over 6. If that's your new period, just like your axes family was divided into 4 equal sections, you can divide this into 4 equal sections. And instead of multiplying each of these by 1/6, which is possible, the mental math is quite easy. The mental math works like this. Once you figure out your period is 2 pi over 6, does it make sense that this ticky mark right in the middle is going to be half of this one? If I take 2 pi over 6 and cut that in half, I get 1 pi over 6. And then the first one is going to be half of pi over 6. If I multiply pi over 6 by a half, multiply tops of your fractions, bottoms of your fraction, pi over 6 times a half will be pi over 12. And then for the third ticky mark, if one of them is pi over 12, just count. 1 pi over 12, 2 pi over 12. This one would be 3 pi over 12. And you can leave it like that, or you could reduce it to pi over 4. That is up to you. Since our x values are changing, but not our y's, our maximum is still 1, our minimum is still -1, and the cos graph starts at a maximum, and once you have these 4 sections, the following pattern will always happen. Once you're at a maximum, next you're at the center line, then you're at the minimum, back to the center line, back to the maximum. And we've drawn the graph of y equals cos 6x very quickly and very easily. So we're going to notice a shortcut that the inside function is going to help us with. Part B, tan of 2/3 x. We just had to go and add fractions, didn't they? Okay. Tan of 2/3 x, well, that 2/3 is going to be a horizontal stretch. You're going to multiply your x values by 3/2. Again, off to the side. my graph. Here's my normal graph of tan. If I want to do a horizontal stretch and multiply each of my x values by 3/2, we are still going to have asymptotes that keep repeating themselves. We are still going to have x-intercepts that are going to repeat themselves. The x-intercept at 0 is going to stay, because if you multiply x by 3/2, that's not going to change. If you had pi and you multiplied it by 3/2, can you see that you would have 3π/2? And over here, you're going to have negative 3π/2. Your asymptotes, if you had this asymptote was at x equals π/2, and I multiplied it by 3/2, it's going to become 3π/4. And this one, negative 3π/4. This one was at 3π/2. If I multiply 3π/2 by 3/2, I'll get 9π/4. And on this side, negative 9π/4. So we take the key attributes add our arrowheads to the end of the graph, and we've sketched our new graph. The period of tan was pi. You've multiplied your x values by 3/2, so your period is now 3π/2. And finally, part C. We have sine of π/7. And you could write π/7x, or sorry, sine of x/7. You could write x/7 as 1/7 x. That 1/7 is inside the function. That's going to be a horizontal stretch. You're going to multiply x by 7/1. Again, off to the side, you think of your normal sine graph. Your normal sine graph has a period of 2π. Label your axes family. 4 equal sections, a maximum of 1, minimum of -1. Sine graph starts in the middle going up. And again, each of these 4 sections goes from center line to maximum to center line to minimum to center line. Here we have our sine graph. If you multiplied your x values by 7, does it make sense that your 2π value will now become 14π? That your period, which was 2π, is now 14 pi. And if you can find your period and mark it, you just need to divide this into 4 equal sections. I always start with the middle one. If that's 14 pi, half of that will be 7 pi. Half of 7, 3.5, or you could write it as a fraction, 7 pi over 2. To get to the third one, this would be 1 7 pi over 2, 2 7 pi over 2s, 3 7 pi over 2s would be 21 pi over 2. So we've already developed a shortcut for this as well. If you could figure out what your period is, and that's just your horizontal stretch here, you're multiplying your x by 7, you'll get 14 pi. Our max and min will still be 1 and negative 1. A sine graph always starts on the center line going up. So here's our center line. Going up means next I'll be at a maximum. Then back at my center line. Then at a minimum. And finally back at a center line. And we can graph this one period quickly and easily. And after this, it just keeps repeating itself. It just keeps going up and down, up and down, up and down, all the way along. Okay, questions you can circle for this one are 3, C, and D.